Hello! Today we will be discussing the process of dissolving and factors that affect the rate of dissolving. The rate of dissolving is a specific measure that determines how quickly a solute can dissolve in a solvent. The rate of dissolving is mainly a concern when preparing a solution with solid solute and a liquid solvent. And the rate of dissolving is used in many fields, including culinary, science, and engineering. These specialists use a variety of equipment and factors to measure the rate of dissolving, and these factors affect the number of collisions between solute and solvent particles in a given period of time. Some examples of this include agitation, temperature, and surface area. These are all factors that can affect the rate of dissolving.
The first main factor that can affect the rate of dissolving is temperature. Temperature is a measure of the average kinetic energy of the particles in a substance. At higher temperatures, solvent and solute particles have increased kinetic energy and collide more often and more forcefully with one another. More frequent collisions means that solutes tend to dissolve much faster under higher temperatures. Temperature changes can also affect the amount of solute that dissolves. An example of this is that in everyday drinks such as coffee or tea, sugar tends to dissolve much faster when the drink is in a heated state.
So another factor which can affect the rate of dissolving in a substance is agitation. Agitation is the process of stirring or shaking a mixture, either with a ladle or alongside a container as a whole. Stirring or shaking a mixture increases the rate of dissolving by increasing the number of collisions between solute and solvent particles. This method can also better distribute solute particles throughout the solvent. Agitation is one of the most common methods used to increase the rate of dissolving in day-to-day life. For example, stirring sugar, which is a solute, makes it dissolve faster in coffee or tea. And stirring juice or lemonade made from a liquid concentrate also increases its rate of dissolving.
Surface area. The surface area of a substance is another factor which plays a key role in the rate of dissolving. The rate at which a solute dissolves is based on the size of the separate solute particles. The given mass of a solid solute has a greater surface area when the individual grains or crystals of the solute are smaller. A given amount of solute dissolves faster when ground into smaller particles as its surface area increases. Increasing the surface area of the solute thereby increases the amount of solute particles in direct contact with the solvent. As a result, more particles collide with each other and the solute dissolves faster. This principle of surface area is why sugar and other flavorings are often found in packets filled with tiny individual grains as opposed to cubes. A sugar packet has a significantly larger surface area in the solvent and dissolves much faster than a sugar cube. Summary and conclusion. Let's summarize what we've learned so far. The rate of dissolving determines how quickly a solute can dissolve in a solvent, depending on three factors, which are temperature, agitation, and surface area. Temperature accounts for the amount of kinetic energy in the solution, or how hot the liquid is. Agitation accounts for how much of all the particles in the solution are directly colliding with each other, which can be increased by simply stirring the solution. And surface area accounts for how much solvent can surround and directly contact the surfaces of the solute particles. Now that you understand the factors that affect the rate of dissolving, think about ways you might be able to apply this concept in your daily life, such as by grinding up sugar cubes if you urgently need to dissolve them in a pot of water. Anyhow, we hope you've enjoyed watching this lesson video, and until next time, see you later.